You are all welcome to today's meeting. At our last meeting, we were able to do something about the linear function. So today we are going to continue from where we ended at our last meeting. And today we are moving on to linear equation. So by the end of today's meeting, you should be able to determine the types of solutions a given linear equation has. Solving linear equations involving one variable. Solve two linear equations using elimination method. And then solve linear equations simultaneously using substitution methods. So now let's move on to how to solve linear equations. But before we move ahead, let's look at the theorem that we are now going to use when solving linear equations. So theorem says that given a linear equation AX equal to B, where A and B are real numbers, they are constants. So to be here, we have the variable to be X. Now, if so, 1, if A is not equal to 0, it means when A is not equal to 0, then the equation has a unique solution. That is when A is not equal to 0, it means we can now solve for X by dividing the left side by A, the right side by A. And that solution is called the unique solution. The unique in the sense that it has only one solution since we are dealing with the linear equations. So this, wherever you go and you are solving such equation, the answer is the same, irrespective of where you are. That's what we call unique special solution or unique solution. Now, such equation, which is the form of AX equal to B, we call it conditional equation. Conditional equation. So they are conditions because the answer or the solution for X depends upon the value of A and B. So we call them conditional solutions. So that's the first theorem or first condition. Now, if A is also equal to 0 and B is not equal to 0, so when assuming A equal to 0, when 0 multiplied by X, you get the left side equal to 0. And B is not equal to 0, B can be any real number like 2. So we are going to have a situation where we have 0 equal to 2. And 0 can never be equal to 2 in any way. And for that matter, what happens that it means there is no way we can let 0 be equal to any other real number apart from 0 itself. So such equation has no solution. Such equation whereby A equal to 0 and B is not equal to 0. So such equation has no solution. So we are having where A is not equal to 0. Whenever we solve for that equation, we are not going to have a special solution or unique solution. And that equation is called conditional equation. But when A equal to 0 and B is not equal to 0, whenever you come across such equation, or maybe you are solving and at a given point, you find out that you are having the one side equal to 0 and other side equal to different number. What happens that way? The equation has no solution. At times we say that the question is wrong. Not that the question is wrong, but that equation has no solution. So that's the second condition. Third one, if both A and B are zeros. If A equal to 0, B is also equal to 0. So here we have A equal to 0, so A 0 times X will be 0 at the left side, and B is also equal to 0. So we are going to have 0 equal to 0. Therefore, here, any value at all that you give to X, the equation will balance. Because for the equation, at the end of it, what value you get for the X, when you put it back into the equation, the left side must be equal to the right side. That's the meaning of equation. The equation must be balanced at both ends. So if you are having A equal to 0, 0 times X is 0 at the left side, B is also equal to 0. So we are having 0 equal to 0. So I can write here 0x equal to 0. So if I give x equal to 1, 1 times 0 is 0, which holds. If I give x equal to 10, 10 times 0 is also 0. So any real number that you give to x, the answer will still be 0. Therefore, such equation has so many solutions. So when it happens that way, we say that the equation has infinitely many solutions. Infinitely many solutions. And such equations are called identity equations. Identity equations. I hope you are following. Good. Let's move on. Steps in solving linear equations. When solving linear equations, you follow some steps to make it very simple for you. So let's see them. Now, if there is or there are brackets, all what you can do there, in case you are solving for linear equation, you see brackets or brackets inside. To move ahead or to get rid of the brackets, we have to do the expansion. We have to expand to remove the bracket or brackets. Again, if you are also having fractions, now at times it becomes very difficult for you to work with the fractions. So when you are having a fraction in the linear equation, you can get rid of the fraction by multiplying all the terms of the equation by the LCM. So we find the LCM of the denominators and multiply each term of the equation by that LCM. So after you have done all this, you have removed the brackets, you have removed the fractions. Now we can group like terms. We group like terms. And now finally we simplify. Good. So before we move on, let's look also at some basic principles of operations. Some basic principles of operations. Now we know from the KG or from the basic schools, we say when positive number crosses equal sign, it changes to become what? Negative. In the same manner, when negative also crosses equal sign, it becomes positive. So positive goes with negative, and negative also goes with positive. In the same manner, when multiplication crosses equal sign, it changes to become division, and when division also crosses equal sign, it also becomes multiplication. So these basic principles were able to solve for linear equations. So don't forget them. Now let's look at the examples. Solve the following equations. 2x equal to 8. I, 3 over 4x equal to 5. I. 3x plus 4 equal to 3 into bracket, x minus 4 bracket closes. Then IV. 2x minus 6 equal to 2 to bracket, x minus 3. So let's see how you can solve for these examples. So I'm going to I, 2x equal to 8. Now when we go back to our theorem 1, we said that if you're having ax equal to b, where a is not equal to 0. So here by comparing ax equal to b to 2x equal to 8, we can see a is equal to 2. So to me, a is not equal to 0. Hence, this equation has unique solution. I think remember. So A equal to 2, not 0. And when we happen that way, we have to find the solution by dividing 12 by the number which is multiplied by the variable x. Because the number is multiplied, if you want to send it to others, we have to divide. So we divide here by 2, here also by 2. So that's what we have here. So we have 2x over 2 equal to 8 over 2. So by simplifying this, 2 go to 2 here, we get x here, and this one we get 4. Therefore, we have x equal to 4. So you see that we are now getting the unique solution, which is x equal to 4. Just one solution because the linear equation. Okay. So now let's move on to II. 3 over 4x equal to 5. Now here, we said that when we have fraction, we find the LCM and multiply all the terms by the fraction. I think you remember it. So we have 3 over 4, denominator is 4. When can we have 5? I know every whole number can be written as that number over 1. So here you can see that it is also 5 over 1. So we have denominator also be 1. So therefore we have 4 and 1. And the LCM between 4 and 1 is 4. So to get rid of this fraction, we have to multiply 2 by the LCM, which is 4. So multiply 3 over 4 by 4, and the 5 also by 4. But before they here again, by comparing this one to the equation AS equal to B, we also see that A is not equal to 0. A is 3 over 4. Hence, this equation also has a unique solution. Good. So by multiplying 2 about the LCM 4, we have 3x equal to 20. Because we have multiplied 3 over 4 times 4. 4 will cancel the 4, leaving here 3x. And 5 times 4 is also 20. That's why you see it here. So we cannot further make x the subject by dividing, because 3 is multiplied by x. So you want to send it to the right hand side, you must divide. I say multiplication goes to division. So dividing here by 3, dividing here by 3, we have x equals 3, 20 over 3. And the unique solution now is 20 over 3. Good. I. Here also, we are having brackets. I said when you have a bracket, you have to expand to remove the bracket. So at this, the right hand side here, we have multiplied the 3 by x and 3 also by minus 4 to get rid of the bracket. So you have 3x plus 4 here, 3 times x, 3x, 3 times 4 is 12. Therefore, we have 3x minus 12. Now, you don't have a bracket anymore, you don't have a fraction also. So we can now move ahead to group like terms. So you can send 3x to the left side, but the sign here is negative, positive when you come here become negative. That's a basic principle. So we have 3x minus 3x equal to, now you are having 4 must also go to the right hand side. And 4 here is positive when it cross become negative. So you have minus 12 minus 4. So here we have 3x minus 3x becomes, let's say 0x, which is the same as 0, equal to 12x minus 4, negative 12 minus 4. That will give us minus 16. So you see that you are coming to a point whereby we are having ax equal to b. I think remember it, ax equal to b. Now we said when a is equal to 0 and b is not equal to 0, now we said that that equation has no solution. Because if I want to make x the same, I will divide here by 0, here also by 0. And you can divide any number by 0. Any number by 0 is undefined. That's why we are saying that. So dividing here by 0, here also by 0 becomes x equal to minus 16 over 0, which is undefined. You can check it with your calculator. Negative 16 over 0. You can check it. So when it happens that way, it means this equation has no solution. This equation has no solution. Because if you simplify, we are not going to get 0 equal to negative 16, which is impossible. There's no way we can make 0 be equal to negative 16. So therefore, the equation has no solution. I think that point is also clear. Let's the ID. 2x minus 6 equal to 2 into bracket x minus 12. Now here again, you're having a flash bracket, and for that matter, we have to get rid of it by expanding. So you have 2x minus 6 here. So multiply 2 by x, we get 2x. Multiply 2 by 3, we get 6. Therefore, we have 2x minus 6 equal to 2x minus 6. No flashing, no bracket. So we can now group like terms. So we can send 2x to the left side and 6 to also the right side. So we have 2x minus 2x equal to 6 minus 6. Now 2x minus 2x, we can get what we call 0x, which is same as 0. So 0x, 6 minus 6 is 0. So we are having 0x equal to 0, which is in the form of ax equal to b. By here, a equal to 0 and b equal to 0. So in the theorem, we said when both a and b are 0, it means therefore that equation has infinitely many solutions. So I said comparing 0x equal to 0 and ax equal to b implies a equal to 0 and b equal to 0. Hence, the equation has infinitely many solutions. Thus, any value at all you give to x will satisfy the equation. I said for the equation, any value give to a variable should be able to balance the left and the right. The left hand side should be the same as the right hand side. That's the meaning of the equation. So if I give any value at all to x, the answer will be 0. So that's the meaning. So therefore, x will take all real numbers. So here it is not a unique solution. Good. Note the following principles. Or we have done that principle already. Okay. So let's move on to example 2. Solve the following equations. 2x minus 3 into bracket 2x plus 4 equals 8 minus 4x. II 2 over 3x plus 3 into bracket into 1 over 2x minus 2 bracket closes minus 6 equal to 4 into bracket 5x minus 7 bracket closes. We have 10x equal to 2 into bracket 3 plus 4x bracket closes equal to 7 minus into bracket x minus 2 bracket closes. IV 3 into bracket x minus 4 bracket closes minus 5 into bracket 6 minus x bracket closes equal to 2 into bracket 4s minus 21 bracket closes. So let's see how to solve them. So for the first one, our problem here is the bracket. So let's get rid of the bracket by expanding at the roots or the steps of solving linear equations when there's a bracket. So we have 2x minus 3 multiplied by 2x becomes minus 6x. Don't forget, negative sign is affecting the 3. So when you are multiplying 2, we have to also include the negative sign. So we have minus 3 times 2x is minus 6. Now minus 3 times 4 is minus 12 equal to 8 minus 4x, as you see here. So now no more brackets, so we can even further simplify the left side. We have then the like terms 6x and 2x. So 2x minus 6x becomes minus 4x, now minus 12, equal to 8 minus 4x. So we can now group like terms, sending x to one side and then the constant also to other side. So by sending minus 4x to the left side and then minus 12 also to the right side, we have minus 4 plus 4, minus 4x plus 4x equal to 8 plus 12. So minus 4x plus 4x, we can see it is now equal to 0x equal to 8 plus 12, which is 20. So if we compare this one to the form ax equal to b, we said when a equal to 0, then the equation has no solution. So here we have a equal to 0, but b is also equal to 20. So a equal to 0, but b is not equal to 0. Therefore, this equation has no solution. So we should be able to identify when it comes to this point, because we can't get 0 over 0. Or when you divide 0 by the left side, get x, 0x over 0 equal to 20 over 0. You can divide a number by 0. You can also check this one. Use your calculator to compute 20 over 0 to see what you're going to get what you call the undefined. So when it happens that way, it means the equation has no solution. I. For the I, we are having flashes. We are having brackets. So we can choose to expand first to get rid of the flash brackets, and then later we multiply to by the LCM. Or we can just multiply by LCM first, and then later we expand. So any step that you want to follow, you can take any one first. Either you are expanding first, or you also multiply by the LCM. But for this one, I expanded first. So let's see how I did that. So we have 2 over 3x plus now 3 times 1 over 2x becomes 3 over 2x. Now 3 times minus 2 becomes minus 6. Now we continue minus 6 here equal to 4 times 5x becomes 20x. 4 times 7 becomes 28. So we have now expanded, so no more bracket. But we are also having flashes. So let's find the x. We can even simplify this. We have the like terms at the left side. Minus 6, minus 6. We can even simplify that one first. So we have 2 over 3x plus 3 over 2x minus 12. Minus 6, minus 6, minus 12. Equal to 20x minus 28. So the denominators for the fractions are 3 and 2. So the LCM will be 6. 3 can go to 6, 2 can also go to 6. So the lowest common multiple is 6. That's the LCM. So to remove the fractions, multiply first term by 6, did by 6, did by 6, did by 6, and did that by 6. So you have to multiply throughout by 6. That's the LCM. That's what you see here. So whenever you see the bracket, it's multiplication. Good. So 6 times 2 over 3x. 3 goes into 6, 2. 2 times 2 will be 4. If you have a calculator, can you use that one to compute it? You can 6 multiplied by 2 over 3. See the answer. Plus now 6 multiplied by 2, 3 over 2. Now 2 goes to 2, 1, 2 goes to 6, 3. So 3 times 3, which is 9x. Minus 6 times 12 is 72. Equal to 6 times 20x is 120x. Minus 6 times 28 is 168. Good. So you see that we have now removed the fraction also. Hence, we can now simplify. Since we have the like terms at the left side, x. So 4x plus 9x becomes 13x minus 72 equal to 120x minus 168. Hence, we can group like terms. So we can share 120x to the left side, and they also send 72 also to the right side. So when 120 goes here, we have become negative. So we have 13 x minus 120x equal to 72 is negative, so we can positive. So 72 minus 168. So when you further simplify, we have 13x minus 120x will give us negative 107x equal to 72 minus 168 will be negative 96. So here you can see that we can express this one as ax equal to b, where a is negative 107 and b is negative 96 rather. So a is not equal to 0 and b is also not equal to 0. Therefore, we will have a unique solution. And you can find that solution by dividing to about negative 107. So that's what you see here. So neg 107, you get x equal to neg 76 over neg 107. Negative will cancel negative, because we learned that at the basic school, negative times negative is positive. So therefore, x now becomes 96 over 107. Don't say 107, because O is a number, a variable, or alphabet. O is alphabet, not a figure. So it's 107. So we're having the unique solution as 96 over 107. Good. Now taking the third equation. So you can get x1, the brackets. So we have 10x minus 2 times 3 is minus 6, minus 2 times 4x is minus 8x equal to 7 minus. Now this one, we are having 1 here by room right. So the same as 7 minus 1 into bracket x minus 2. Or we can get multiplied by negative 2 out. So negative times x becomes negative x. And negative times negative 2. Negative multiplied by negative becomes positive. So you have positive 2. Good. I hope no problem here. So now you cannot simplify because you're having like terms at the left and the right. So you're having 10x minus 8x. That will become 2x now minus 6. When you go here, you're having 2 plus 7 plus 2, which is 9. So minus x. So you have 2x plus 6 equals 9 minus 6 minus x. So we cannot group like terms. So sending x here and 6 here, we have 2x plus x equals 9 plus 6. Therefore, we have 3x equal to 15. So here a is 3, which is not equal to 0. B is also 15. So therefore, this equation has unique solution. And you can find it by dividing through by 3. So here by 3, here by 3. Therefore, the solution now becomes 15 over 3. Good. So going to the IV, the same thing, we do the expansion for all the brackets to open them up. So 3x, 3 times 4 minus 12, minus 5 times 6 minus 30, minus 5 times minus x becomes plus 5x. Negative times negative, we get positive. Equal to 2 times 4x becomes 8x. 2 times minus 21 becomes 42. So here you can simplify the left side because you haven't like terms. So 8x plus 5x becomes, or 3x plus 5x becomes 8x. Minus 12 minus 30 becomes minus 42. Now equal to 8x minus 42. So we cannot group like terms. So we are now having 8x minus 8x equal to 42 minus 42. So this one will give you 0x equal to 0. Therefore, we are having a situation where a equal to 0 and b is also equal to 0. Hence, the equation has infinitely many solutions. Good. So I've explained that one to you. And such equation, we call it identity equations. So you can try these equations. You are now going to identify the equations and hence solve for those that you can solve. Okay, let's move on to simultaneous equations. Given the two linear equations, a1x plus b1y equals to c1, a2x plus b2y equals to c2. So here you have equation 1, equation 2, where a1, b1, c1, a2, b2, c2 are constants. They are real numbers. So to make the two equations, you are having two variables which are x and y. So if you are having two equations with two unknowns or variables, we can use simultaneous approach to solve them. We can solve them simultaneously. Good. So the two equations can be solved simultaneously using, now the method that we can use to solve simultaneous equations include elimination method, so simultaneous by using elimination, substitution method, graphical method, and the matrix approach. But for the sake of our course, we are now dealing with only the first two. Good. If we get admission, we may use all of them. So now let's tackle the elimination method. Now let's consider the equations. a1x plus b1y equals to c1, name it equation 1. a2x plus b2y equals to c2, name it equation 2. So now we can choose to remove the variable x or y, because we are only two variables, x or y. So you can take one out and solve for the other one. That would be called the elimination method. So now in case we want to eliminate, let's say, x, we're going to take the variable x out and solve for y. We can follow the following steps. Now step 1. Now steps. If a1 equal to a2, now if the numbers multiplied by x in the first equation and the number multiplied by x in the second equation are equal, that's a1 equal to a2. If so, then we can add the two equations. So we can add equation 1 and equation 2. If a1 and a2 has different, if they have different operation sign, that is when maybe a1 is negative and a2 is positive, or a2 negative, a1 positive. If they have different sign, then we can add the two equations, x will go away. That's one of the conditions. Again, if a1 equal to a2, then we can add the two equations when a1 and a2 have different operation sign. That's when one is negative and one is also positive. When one is negative and other one is also positive, negative. Then we add the two equations to get rid of x or to remove x. Good. So after we have done that, so we are now subtract one equation from the other when a1 and a2 have the same operation sign. So if a1 and a2, a1 here and a2 here are having the same sign, that's a1 is positive, a2 positive, or a1 negative, a2 also negative. When it happens that way, we also subtract one equation from the other. So I can subtract equation 1 from equation 2, or equation 2 from equation 1. When the a1 and a2 have the same operations. And we are having two conditions. 1, if they have different operation sign, we add. If they have the same operation sign, we subtract. Take note of that. So after you've done this, now you'll be left with only one variable, which is y. So we have to solve for y, using how to solve for linear equations. Then after you have gotten your y, now you go back to any one of the equations and then you substitute the value of y that you have gotten into that equation. So in case we got y to be, let's say 4, I can go to equation 1 and whenever I see y, I put the 4 there. Or I can take equation 2, whenever I see y, I put the 4 there. So it can take any one of the equations, either 1 or 2, and then substitute the value of y that you have gotten back into that equation. Good. So that's what we have. So substitute the value of y into any one of the equations so as to solve for x. That's the first condition. Now the first condition is if a1 equal to a2. Now what about if a1 is not equal to a2? What should we do? What we are going to say remove x, but a1 is not equal to a2. Now when a1 is not equal to a2, we can first multiply equation 1 by a2. That's the coefficient of x in the second equation. So I'll take the coefficient of x in the second equation and multiply it by all the terms in equation 1. Then you take the coefficient of x, which is a1 in the first equation, multiply by all the terms of equation 2. So multiply equation 1 by a2, equation 2 by a1. When you do this, you make the a1 equal to a2. When you do that, you make a1 equal to a2. So you can also try that step. So you can multiply 1 by a2 and equation 2 by a1 to make them equal. Then after that, you follow the steps to check if a1 equal to a2. If a1 and a2 have the same sign, then we subtract. If they have different sign, then we add. And then we also solve for y and then do this necessary substitution. I hope you are following. Good. So you can also do the same thing in case you want to eliminate y. The same principle. Check the coefficient of y and then see if they're the same and so on and so forth. Let's look at example 1. Solve the following equation simultaneously using elimination method. X plus 2y equal to 3, x minus 3y equal to 8. So see this one, you can easily eliminate x. So we have our a1 is 1. The number that is multiplied by x, or the coefficient of x in equation 1 is 1. Coefficient of x in equation 2 is also 1. So to me, you can say the a1 equal to 1, a2 equal to 1. Therefore, a1 equal to a2. So our first condition holds. Now, if so, now let's go and check the sign. Now, this is positive for 1, this is also positive. Therefore, since you have the same sign, then you can subtract any one equation from the other. Good. So that's why I said the coefficient of x in both equations are equal. That is a1 equal to a2. We can subtract one equation from the other since they are all positive. So we have x plus 2y equal to 3, equation 1, x minus 3y equal to 8, equation 2. So here I am subtracting equation 1 from equation 2. So I said equation 2 minus equation 1. I am subtracting equation 1 from equation 2. So when I come here, I have equation 2 here, which is x, minus equation 1, which is x. So we can x minus x, x minus x. That will be 0. So x is now out. Now when we go to the y, the y in equation 2 is minus, so we have minus 3 minus, the y in equation 2 is also what? 2y. So minus 3 minus 2. Minus 3y minus 2y. and that will give me minus 5y. I hope you are following. You have written here as 2, either equation 2 minus equation 1. So you just take equation 2 term first. Now subtract equation 1 from it. So equation 2 here is x. So you have x minus equation 1 here is x. That will give me x minus x, which is 0. So x is away. Now we go to the next step. Equation 2 here is minus, so we have minus 3y. Minus equation 1 here is also 2y. So we have minus 3y minus 2y. And that will give me minus 5y. Now when I go to the right hand side, we have equation 2 here is 8. So we have 8 minus equation 1, which is 3. So we have 8 minus 3, which is also 5. So here you are left with only y, and you can solve for y by dividing here by negative 5, here by negative 5. Don't forget, this one is also in the form of ax equal to b. So here our a here becomes negative 5, which is not equal to 0. And b is also not equal to 0. Therefore, we have the unique solution for y. So we have y equal to negative 1. Now that you have a y, let's go back to the equation that you have, either equation 1 or equation 2, and substitute the value of y into that equation. So by taking equation 1, you can take equation 2. So by I took equation 1, by taking equation 1, I have x plus 2. We are having y here, but here we know y to be minus 1. That's why we see minus 1 here. Now equal to 3. So we are not going to have x. 2 times minus 1 is minus 2. So we have x minus 2 equal to 3. We not solve the linear equation, so this one won't matter. Therefore, x becomes 3 plus 2 is 5. So to make the solution, our x equal to 5 and y equal to negative 1. Good. I hope you are following this steps. Now let's move on to the second example. Solve the following equations simultaneously using elimination method. Solve the following equations simultaneously using elimination method. Now here we have 2x plus y equal to 10. 4x minus 2y equal to 12. So looking at the coefficient of x in both equations, a1 is 2, a2 is 4. In case you want to remove the y, now the coefficient of y in both equations, a1 is 1, a2 is minus 3. So they are not the same. They are not the same. So this time I chose to eliminate y. You can also eliminate x first. So because the first one we eliminated x, now this I want to eliminate y. So that you won't see that always want to eliminate x. No. So I chose to eliminate y. So I said b1 is not equal to b2. So b1 is 1, b2 is minus 3. Therefore, what should we do? Now, we said when it happened that way, we multiplied equation 1 by, now here we are using b1 and b2. So we multiply equation 1 by b2, now equation 2 by b1. You multiply equation 1 by b2, equation 2 by b1. So we multiply the whole equation 1 by b1 is 3. So multiply this one by 3, and then you multiply equation 2 also, the b1 is also 1. Equation 2 also by 1. So multiply equation 1 by 3 and equation 2 by 1. That will give me so you have this, that, so 3 times 2 will be 6x, 3 times y will be 3y, equal to 3 times 10 will be 30. So I'm done with equation 1. I've multiplied equation 1 by the coefficient of y in equation 2. So I'm going to also multiply equation 2 also by coefficient of y in equation 1, which is 1. So by multiply 1 by any number, I get the same thing. So to me, equation 2 will remain the same as we see it here. So when you multiply, the new equation now here is equation 3, and here becomes equation 4. Therefore, now we have the same here, we have 3y, 3y. So now that the coefficients are the same, we can now check to see if they have the same sign or different. Here it's positive and here it's negative. So they have different signs. And when we say they have different signs, what should we do? We add the two equations. But when they're the same, we subtract. So since we have this one, 3y minus 3y, we cannot add the two equations because one is positive, one is negative. So by adding equation 3 and equation 4, so 6x plus 4x will give me my 10x. 3y plus minus 3y will be 0, so y goes away. Because 3y plus minus 3y will become the same as 3y minus 3y. Now equal to 30 plus 12. 30 for equation 3 plus 12 for equation 4. That will give me 42. So we have come to the point where we have ax equal to b, where a is not equal to 0 and b is not also equal to 0. Therefore, you are not going to have unique solution. So by dividing 2 by 10 here by 10, we have x equal to 42 over 10. So we can even simplify further. 2 can go here, 2 can go here. So here will be 21 over 5, which is the same as 4.2. Can you use the calculator? Check that. Now that we know why, we cannot go to take any one of the equations and substitute x equal to 4.2 into that equation. So now we took equation 1. We are going to equation 1 wherever we see x, we just write the value 4.2. So we are 2 to bracket 4.2 plus y equal to 10. Therefore, multiply 4.2 by 2, we get 8.4. So we have 8.4 plus y equal to 10. Now sending 8.4 to other side, it becomes y equal to 10 minus 8.4, which is 1.6. So now we have the solution as x equal to 4.2 and y equal to 1.6. And these are the unique solutions. I hope it's okay there. Now let's go to the third examples. Now here we are not using our usual x and y, but you can use any variable at all. Not all the time that you are going to get x and y. So here I'm using m and n. So solve the following equations simultaneously using the elimination method. 2m plus 3n equal to half into bracket m minus 5, bracket closes plus 3n. Then the next equation becomes 3m minus 5n equal to 7m plus 2n minus 10. So here, before we apply any method to solve them simultaneously, we have to simplify them. So therefore, let's simplify the first and second. So going to the first equation, we are having fractions and the brackets. So we can multiply 2 by the LCM and then we expand. Or we can expand and then multiply 2 by the LCM because we are having both fraction and bracket. So by doing so, let's expand first. So multiply LCM is 2, so multiply here by 2, here by 2, here by 2, here also by 2. You know why? Because we have only one denominator. Or we have the 2 here at the LCM. Because we have this over 1, this over 1, this over 1. And the common one is what? 2. The common lowest common multiple is 2. So now, by multiplying, here by 2, here by 2, here by 2, and so we are now going to have 4x plus 2 times 4n, no, 4n plus 8n equal to, now when 2 multiplied by half, you get 1. So to me, 1 multiplied by the bracket, you get the same thing. So it's m minus 5 plus 2 times 3n. That will give us 6n. Let me go back again. So multiply here by 2 will be 2 times n, 2m will be 4m plus 2 times 4n will be 8n equal to 2 times half is 1. So it means we have 1 into bracket m minus 5. I would do the same as m minus 5. That was the m minus 5 there. Now we are saying multiply 3n by 2, which is 6n. So now let's simplify them into the form a1 plus or a1x plus b1y equals c1. So when we can now group like this, so we can send m to n, m to n. So we have 4n. Now when m goes here, it becomes 4m minus m, which is 3m. When 6n also go to the left side, it becomes 8n minus 6n, which is 2n, equal to minus 5. So now we now get our simplified equation for equation 1. Agree? Now, if you send all m and n to the left side, it becomes 4m minus m, you know why? Plus 8n minus 6n equal to minus 5. So when you simplify that way, that will give you 3n plus 2n equal to minus 5. Equation 1. Now from equation 2. So because you don't have a problem, the matter of sending all to the other side or the left side and leave the negative term at the right hand side. So this will be 3m minus 7n minus 5n minus 2n equal to minus 10. And when doing so, we are now going to get minus 4m minus 7n equal to minus 10. Equal to minus 10. So now, 2n plus 8n equal to minus 12, equation 3, minus 12m minus 21n equal to negative 30, equation 4. So since we have different sign, we have to add equation 4 and equation 3. So we add 12m plus 12m plus minus 12m, that all goes away. Now when we can get, we are now having 3n plus minus 21n, and that will give us minus 13n equal to minus 20 plus minus 13, which is also minus 50. So by dividing now, we cannot get n equal to 50 over 13. Now that you know n, we cannot substitute this n, 50 over 13, into any one of the equations, either equation 1, equation 2. So I took equation 1. Therefore, substituting n equal to 50 over 13 into equation 1, we now have 3n plus 2 into bracket 50 over 13 equal to negative 5. So you're now having a fraction. So you can now get multiplied by the LCM, which is 13. So 3n by 13, 2 into bracket 50 over 13 by 13. Now minus 5 also by 13. So what happened that way, we are now going to get 39m plus 100 equal to negative 65. 3 times 13, 39. 13, go to 13, leaving 2 times 50, which is 100. Minus 5 times 13 is all 59. Okay. So with that, we cannot make m the subject by sending 100 to the right hand side. To get it 9n equal to 1, 6, the negative 165. Negative 165, not positive. So therefore, we have n now equal to negative 55 over 30 when you simplify that. So you can try this on your own. Take your time and do them. Let's go to a substitution method. Substitution method. Now, taking the same two equations, a1x plus b1y equal to c1 equal to equation 1, a1, a2y, a2x plus b2y equal to c2 equation 2. Then steps, take any one of the equations and make either x or y the subject. So you can take equation 1 and make x the subject or y the subject. You can also take equation 2 and make x or y the subject of that equation. So after you have done that, then you substitute the resulted equation into the other equation. So in case I took equation 1 and I make x the subject, now what about going to be equation 3? So I come to equation 2, don't take equation 1 again. Go to the other equation, to equation 3. And whenever you see x, whatever you got from equation 3, you put it there. So substitute the resulted equation into the other equation. So after doing this, it means you have now removed one of the variables. Solve for the value of the remaining variables. And then for the other variables, you also solve for that one by doing another substitution. So let's look at the example. Solve the following equations simultaneously using the substitution method. X plus 2y equal to 3. X minus 3y equal to 8. We solve the same equation using the elimination. So we are now using the substitution and see. So we can take any other equation 1 or equation 2. So taking equation 1. Taking equation 1. We can make x the subject because x is very simple when you are making the subject as compared to y. So we send 2y to the right hand side to get x equal to 3 minus 2y. And this one we name it equation 3. We took equation 1, so this time we are not going to take equation 2, the other equation. And whenever you see x, you put 3 minus 2y. So we substitute equation 3 into equation 2 to get 3 minus 2y, which is for x. Now minus 3y equal to 8. So that's why we get 3 minus 5y equal to 8. Therefore, y equal to 1, negative 1. Now you can go ahead and put substitute y equal to negative 1 into any one of the equations. This time you can even take equation 3. So if you take maybe equation 3, we have x equal to 3 minus 2y. But now you know y is minus 1. So it becomes x minus 2 into bracket minus 1 equal to 5. because we have here 3 minus 2 minus 1 becomes plus 2. Now equal to 5. Therefore, we have x equal to 5 and y equal to minus 1. So solving example 2 as we did to the elimination method. So we are taking equation 1, y is having a coefficient of 1. So I can make y the subject of equation 1. After I'm ready to do that comparisons. So from equation 1 making y the subject, we are now going to get y equal to 10 minus 2x. I will name that y equation 3. So y equal to 10 minus 2x. Now we took equation 1, so now we are now going to equation 2. So let's substitute y equal to 10 minus 2x into equation 2. And that will give us 4x minus 3. Now this is equation 2. Equation 3. 10 minus 2y. 2x is the same as y. Y equals 10 minus 2y. So here it's y. So 10 minus 2y. Now equal to 12. I hope you are following it. So we have a bracket, we can do expansion. So let's do the expansion. So we have 4x minus 30 plus 6x. This is minus 3 times 10 minus 3 times minus 2x. So plus 6x equal to 12. So by simplifying, we now have x equal to 4.2 as we had it when using elimination approach. So now you can continue just to find the y. You continue yourself. So find the y by just substitute x equal to 4.2 into equation 3 or any one of the equations. You get your y. Okay. So you can do that one also for the third equation. Solve the following equations simultaneously using substitution method. 3m plus 4n equal to half into bracket m minus 5 plus 3n. We are having equation 2, 3n minus 5n equals 7n plus 2n minus 10. So before we move on, we have to simplify each one of them. So we are now having equation 1 as 3n plus 2n equal to minus 5. Equation 1. Now when we simplify equation 2, that one will also give us so we have 3m plus 2n equal to minus 5 minus 4m minus 7n equal to minus 10, equation 2. So by taking one of the equations, so here I took equation 1. So from 1, I made n the subject. So when 3n is sent to the right hand side, it becomes 2n equal to minus 5 minus 3n, or minus 3n minus 5. Then by divide through by n to make n the subject, divide through by 2 to make n the subject, I will get n equal to negative 3 over 2m minus 5 over 2. Again, when you send 3n to the right hand side, it becomes 2n equal to minus 3n minus 5. Then dividing throughout by 2 to make n the subject, I'll get n to be equal to negative 3 over 2n minus 5 over 2. And that's why it's equation number 3. So we have equation 3 here. So it means We got this equation 3 from equation 1. So therefore, we are now going to substitute equation 3 into equation 2. So we are putting equation 3 into equation 2. So we have equation 2, we have minus 4m minus 7. And n now is this. Negative 3 over 2m minus 5 over 2. That would have C. Now equal to minus 10. So by we are having a fraction and then we also have brackets, so you can get expand. So by expanding, we got this minus 7 throughout. So that will give you this, so you can try that one. Then after that, multiply 2 by the LCM. That will give us minus 13m plus 35 equal to minus 20. So by sending 35 to this side and divide by 13, we have m equal to negative 55 over 13. So now you know m. So you can just go ahead and put m equal to negative 55 over 13 into equation 3 or any one of the equations. So by this, we are not going to get n equal to 3 over 2, negative 3 over 2 into bracket. This is my m. So minus 55 over 13, now minus 5 over 2. So when I simplify this one, it will give me, by expanding to give me this and simplify, I'll get my n to be equal to 50 over 30. You can go through the process and check everything. So I think at this point we can end here. And now you have to go over and over again for you to get more understanding. Thank you for coming. I hope to see you at our next meeting.